Hey guys, welcome back to my YouTube channel, and in this video we'll try to solve this problem which we have discussed in the previous video. Okay, so in the previous video we have discussed like how we can find out that whether n1 and n2 are on same path or not. So we just need to find out that whether n1 is the part of subtree which is found by n2 or not, or vice versa, means n2 is the part of subtree which is found by n1 or not, means either of these two conditions are satisfied. So we can say that n1 and n2 are on same path, right? But this solution is not feasible. I'll tell you why. Let's say if you want to check the first condition, means we want to find out that n1 is the part of n2, subtree of n2 or not. So it will take order of n time, O of n time, right? And this for second condition also, it will take O of n time, means the total will be 2n time. Okay, total time is 2n time. Now let's say if we have n queries, means we have n pair of nodes. Okay, now if I calculate the time complexity now, it will become 2n square, 2n square, and we can remove this constant from here. So overall it will become n square, which is pretty bad. Okay, now how we can minimize this time complexity by solving this problem with some other method? Let's see this. All right. So there is a concept of end time and out time entry data structure. The first one is end time and the second one is out time. Okay, this is out time. So if I talk about the definition of these two times, the first one is end time, and end time is that time when we visit any node for the first time. Let's say if I visit node number 0 for the first time, then its end time will be 1. Okay, and it will keep incrementing. Let's say if I again visit node number 1 after visiting node 0, so here in this case its end time will be 2. Okay, then if I visit node number 3, so its end time will be 3. It will keep incrementing. Okay, so this is the definition of end time. And if I talk about out time, then out time is the time when we visit any node for the second time, but there is one condition. The condition is whatever the nodes that is part of its subtree should be visited. Okay, now let's see, let's check if I want to calculate the out time of 1, so the condition here is we need to visit all its subtrees nodes. Okay, means we need to visit 3, 4, 7 and 8, and after that we are in the position to calculate the out time of node number 1, right? So this is the definition of end time and out time. Now let's calculate the end time and out time of all these nodes. Okay, so first we'll visit 0, its end time is 1. Then again we'll visit node number 1. This is DFS. Okay, DFS traversal, so its end time is 2. Then 3 is end time is 3. Okay, right, now 3 is actually a leaf node. It is 3. Okay, 3 is a leaf node, and just a second. Okay, so 3 is a leaf node and it has no children. Its left child is null and its right child is also null. So we are in the position of calculating the out time of 3. Okay, because whatever the nodes that is a part of its subtree, actually there is no nodes. Okay, so we are in position to calculate the out time of 3. So the out time of 3 will be 4. See, the in time and out time of any leaf node, means the difference between in time and out time of any leaf node is 1. Okay, means the modulo of, this is not modulo, this is actually the mod function. Okay, and if I say the in time minus out time, its difference will always be 1. Okay, so for any leaf node, let's say if the in time of 7 is 1, so its out time will be 2. Okay, because we will not be visiting this node again, and it has no children, means its left child is null and its right child is also null. So we can calculate its out time, because in the definition of out time there is the condition that we can calculate out time of any node if all its subtree is visited. Okay, so this is the formula. Now the out time of 3 is 4. Then there is no nodes below 3, so we'll return back to its parent node. and left child is completed. Now we'll visit its right child. So for node number 4, the end time will be 5, okay, because previously it was 4, so now it is 5. Then we'll visit the left child of 4, and for 7 its end time will be 6, and its out time will be 7 again, because the difference is always 1, okay. So there is no child of 7, so we'll return back to its parent node, and now we'll visit its right child, which is 8, and its end time will be 8 because we are visiting the node for the first time, and its out time will be 9 because it's a leaf node, and this is the condition for end time and out time of leaf node, okay. Now it is completed. We'll again go back to its parent node, and for node number 4 all its nodes are visited, means whatever the nodes which are part of its subtree is visited. So we are in the position to calculate the out time of 4, okay. So its out time will be 10 because previously the timer was 9, and there is only one variable, there is a time variable which keeps incrementing, okay, which keeps incrementing. So the out time of 4 is 10, the end time is 5, and out time is 10, okay. Now this is completed, so we'll return back to its parent node, and for node number 1 also whatever the nodes which are part of its subtrees are visited, so we can calculate its out time now, okay. So the end time is 2 and out time will be 11, 2 and 11, right, 2 and 11. And then we'll again go back to node number 0, and its left hand child is completed. Now we'll visit its right hand child. So for node number 2 the end time will be 12, okay, because previously it was 11, it is 12. Then for node number 5 its end time will be 13, and out time will be 14, okay, because it's a leaf node, its out time will be 14. And again for node number 6 its end time will be 15, okay, and its out time will be 16 because we need to maintain the difference as 1. 15 and 16 is end time and out time for node number 6. And again we'll visit its parent node, so its subtrees are completed. So now the end time of the out time of 2 will be 17, okay, it is 17, right. 12 and 17 is the end time and out time of 2. And then we'll again go back to node number 0, and for node number 0 the out time will be 18 because everything is done, means whatever the nodes that is the part of its subtrees are visited, so we can calculate the out time of 0 now. So 1 and 18 is the end time and out time of node 0. So this is how we can calculate the end time and out time of any node. Now let's check whether, okay, so this is the condition for checking whether n1 and n2 are on same path, means if any of these two conditions are satisfied, we can say that n1 and n2 are on same path, right. So the condition 1 is end time of n1 should be smaller than end time of n2, and out time of n1 should be smaller than out time of n2, okay. Let's take an example. Let's say if I want to find out that whether node 3 and node 2 are on same path or not, okay. So end time of n1 should be smaller than end time of n2, means 3 is smaller than 12, the condition, this is satisfied, this is satisfied. And out time of n1 should be greater than out time of n2, means out time of n1 is 4 but out time of n2 is 17, means this condition is not satisfied. So here the whole condition is not satisfied, or means if the first condition is satisfied or the second condition is satisfied, means we can return true in that case. So if I check the second condition, means end time of n2 is smaller than end time of n1, means end time of n2 is not smaller than end time of n1, so we'll not check the whole condition. So any of these two conditions are not satisfied, so we can say that 3 and 2 are not on same path, okay. Now let's check whether 1 and 7 are on same path or not. So the first condition is end time of n1 should be smaller than end time of n2. So let's take the value of n1 as 1 and the value of n2 as 7. So in time of n1, which is 2, is smaller than 6, so it is satisfied. And outtime of n1 should be greater than outtime of n2, so 11 is greater than 7. So here the first condition is satisfied. Okay, the first condition is satisfied, means we can say that 1 and 7 are on same path, right? Now let's take the example of 5 and 6. 5 and 6. Okay, so in time of n1, let's take 5 as n1 and 6 as n2. Okay, so in time of n1 should be smaller than in time of n2, so here it is satisfied. But if I check the outtime of, okay, and the second condition is outtime of n1 should be greater than outtime of n2, so here outtime of n1 is 14 and outtime of n2 is 16, which is not true. Okay, it is false. So here 5 and 6 are not on the same path, so here we'll simply return false. Okay, so this is how we can check whether n1 and n2 are on same path or not, right? Now let's see the code. Okay, so this is the function for adding edge between two nodes, and here I have created this DFS function. So this is a basic DFS function, and the first thing that we need to do, we need to create a timer variable here. Okay, and initialize this variable to 0, and above it I have created these two arrays. The first one is for end time and the second one is for out time. Okay, and this is the visited array. So what we'll do, we'll keep incrementing this timer variable. Okay, first we need to increment the timer variable, and after that we'll assign this timer variable into this array. So this is for end time, and after visiting all its node, we'll assign or we'll calculate the out time of that particular node. Okay, so this is what we are doing here, and here I've created this function for calculating here. So this is the condition that I've written in this function. Okay, so if this condition is true, then we'll simply return true, and if it is not satisfying this condition, then we are returning false here. And this is the main function. So, and if the condition is true, we'll simply print the path is same, and if it is false, then we are printing different path. Okay, so this is how we are calculating whether two nodes are on same path or not. Now let's run this. So it is compiled, and if I run this, okay, so we need to input two nodes here. So let's take just a second. Okay, let's take node number 1 and 8. Okay, 1 and 8. So it is saying same path, means 1 and 8 are on same path. Now let's take 3 and 2. Okay, 3 and 2. So the path is different for node number 3 and 2. Let's take 5 and 6. Okay, so for that also there is different path. Now if I take 0 and 7, 0 and 7. Okay, so for 0 and 7 the path is same, because 7 is the part of subtree which is formed by 0, or let's say the end time of 0 is smaller than end time of 7, and the out time of 0 is greater than out time of 7, means it is satisfying this condition. It is satisfying this condition. So that's why the answer is this same path. Okay, so this is how we can find out like whether n1 and n2 are on same path or not, and this is the code for it. Okay.